Hi there, my name is Ben. What's your name?
Hello, Ben. I'm so glad you reached out. My name is Chip, and I'm a robotics tutor at Lawrence Technological University. How can I assist you today?
It's very nice to meet you. I was hoping that you could tell me what topics are covered in the robotics program at LTU.
I'm delighted to meet you too, Ben. The robotics program at LTU covers a wide range of exciting topics. We dive into areas such as robot design, control systems, artificial intelligence, machine learning, computer vision, and even the ethical considerations surrounding robotics. We also explore the integration of sensors and actuators, as well as programming languages commonly used in robotics. Is there a specific area you're interested in learning more about?
Sure, why don't you give me a brief overview of the different types of robotic actuators?
Oh, I'm glad you asked about robotic actuators, Ben. There are several types of robotic actuators, each with its own unique characteristics and applications. We have electric motors, which are widely used and come in various forms like DC motors, stepper motors, and servo motors. Pneumatic and hydraulic actuators use compressed air or fluid to generate motion and are often employed in heavy-duty applications. Shape memory alloys, like nitinol, can change shape when heated or cooled and are useful in certain robotic applications. And let's not forget about piezoelectric and electroactive polymers, which can convert electrical energy into mechanical motion. These are just a few examples, but there's a lot more to learn.
Oh, I'm sure there is. Maybe you can compare and contrast forward kinematics versus inverse kinematics as they apply to robotics.
Forward kinematics and inverse kinematics are fundamental concepts in robotics, and I'm thrilled to explore them with you, Ben. Forward kinematics deals with determining the position and orientation of the end effector of a robot given the joint angles. It's like figuring out where the hand of a robot arm will be based on the angles of its joints. In contrast, inverse kinematics involves finding the joint angles required to achieve a desired position and orientation of the end effector. It's like determining the angles of the joints needed to place the robot arm's hand at a specific location. Both forward and inverse kinematics are crucial for controlling and planning robot movements. Do you have any specific questions, or would you like to dive deeper into this topic?
Thank you, but I have a different question. I'm wondering if you are familiar with the acronym SLAM, S-L-A-M, as it applies to robotics.
Absolutely, I'm familiar with the acronym SLAM. It stands for Simultaneous Localization and Mapping, which is a key concept in the field of robotic navigation and mapping. SLAM techniques allow a mobile robot to simultaneously create a map of its environment and determine its own position within that map. By using various sensors, like cameras, LiDAR, or inertial measurement units, the robot can estimate its surroundings and update its own pose as it moves through an unknown environment. SLAM is essential for autonomous robots to navigate and interact with their surroundings effectively. Is there anything else you'd like to know about SLAM or any other topics in the field of robotics?
Oh, I'm sure I'll have many more questions in the future, but thank you for now, Chip. It's been nice talking to you.
It's been my pleasure, Ben. I'm delighted to have had the opportunity to assist you today. Remember, I'm always here to answer your questions and help you with your robotic studies. Feel free to reach out anytime. Have a fantastic day!